Okay, so I'm looking at this spec sheet for Kramer's BC-DGKat7A23 cable, and the first thing that really jumps out at me is in a tech spec.
It's the price, right?
Yeah, the price. We're talking about a 100-meter spool of bulk cable, and the list price is $450.
Yeah, it definitely puts that $5 patch cord you grab at the electronics store into perspective. Even on sale for $360, that's a serious investment.
So that's really our mission for this deep dive then. We have to figure out, where does that money actually go?
What are you paying for?
Exactly. We need to decode this alphabet soup CAT7A, SFTP23AWG, and figure out if this is just marketing or if there's real engineering here.
Oh, it's definitely not marketing. You have to think of this as, well, as infrastructure. This is a component designed for environments where signal loss or jitter just isn't an option.
Okay, so let's start right there with the name itself. CAT7A SFTP. To the uninitiated, that just looks like a serial number.
Well, the SFTP part is the key differentiator. It stands for shielded with foiled twisted pairs. In your standard home Ethernet cable, the little copper pairs are usually just sitting next to each other inside the plastic casing.
Which, works fine for short distances.
Usually, yes.
Yeah.
But here, every single one of the four twisted pairs is individually wrapped in its own aluminum polyfoil shield.
Okay, so that's the FTP, the foiled twisted pairs.
Exactly. And then on top of that, there's an overall tinned copper braid shield that wraps the entire bundle.
Wow, so it's a double-layer defense system. You're isolating the pairs from each other and isolating the whole cable from the outside world.
Precisely. It's all about killing crosstalk. When you're running data over long distances, and this is rated up to 100 meters, electrical interference is the enemy.
So this whole construction is sort of a Faraday cage for your data.
That's a great way to put it.
And that shielding, I assume, is what explains these performance specs. I'm seeing it's rated for a frequency range of 1 to 1200 megahertz.
That is just massive headroom. A standard Cat6 cable might tap out around 250, maybe 500 megahertz.
And that high frequency is what lets it handle 10G-BaseT, that's 10 gigabit Ethernet, reliably.
Yes, reliably. And plus, it's optimized for PoE plus or power over Ethernet.
Meaning it's carrying the data and the electricity to power the device on the other end all at once?
Right. And that brings us to the physical reality of the copper itself. This uses 23 AWG bare solid copper conductors.
23 AWG. Okay, so in wire gauges, the lower the number, the thicker the wire, correct?
That's right. This is physically substantial copper. I mean, the nominal outside diameter of the whole cable is about 8.1 millimeters. It's thick.
Which sounds sturdy, but I did catch a little gotcha in the documentation. You can't just buy this spool, cut a piece off, and crimp a standard plastic connector onto it.
No, and if you try, you'll likely fail. Because of that 23 gauge thickness and all those shielding layers, a standard RJ45 connector just won't fit.
So what do you do?
The specs explicitly state you need custom shielded RJ45 connectors that are specially designed for this diameter.
It also mentions being optimized for Kramer hardware. Is that just a brand lock-in, or is there a real technical reason for that?
It's mostly about impedance matching. They've engineered this cable to work perfectly with their specific digital transmitter and receiver sets. At these speeds, the cable isn't just a pipe.
It's part of a tuned circuit.
Exactly. They want to guarantee the waveform that leaves the transmitter looks exactly the same when it hits the receiver 300 feet away.
So if I'm a listener running a standard home office, I probably don't need to drop $400 on a spool of this.
Probably not today, no. But it's important to understand that the cloud, or these high-end AV installations, they aren't running on Wi-Fi. The backbone of the internet is built on this kind of heavy, shielded, precisely engineered copper.
It's the invisible highway that makes all the speed possible.
It is. And, here's a thought to chew on. Right now, this is industrial-grade gear. But our bandwidth needs at home are just climbing so fast. We're already seeing consumer 10 gigabit hardware becoming more common.
It does make you wonder.
It does. Are we reaching a point where, to truly future-proof our homes, we'll all need to start retrofitting our walls with this level of heavy-duty shielding just to stream the next generation of content?
A heavy thought for a heavy cable. Thanks for breaking it all down.
Anytime.